Welcome back. So talk about 7.2 today, so substitutions. This is probably one of the more important sections that we're going to cover. Your ability to work in 7.2 is a fundamental thing that you're going to need for the rest of this. Okay, so last section was important too because you need those basics. But the better you are at 7.2 is probably the better you're going to do in class. Not everything is this, but being able to see this will help more than size. So let's go ahead and give this a shot. So I'm going to go ahead and share my screen. Let's just start going over what we have for 7.2 here. Okay, so this is substitutions. Okay, so 7.2 substitutions here. So you are inevitably have to make some substitutions. By the way, every time I teach this, I know it comes out of the pen. It always comes out of the pen so perfect. It never comes out of the pencil or your pen. You will make mistakes from this. You will get the wrong substitution. That's okay. That's part of the learning process. Okay. It doesn't happen magically with every wrong. So be prepared when we're trying a problem. Maybe I made the wrong substitution. That check your algebra, check. But leave yourself open to maybe I made the wrong choice at the beginning. It really does happen that way. Everybody who learns this has to deal with the fact that I goofed, I made the wrong substitution. Great, we've erred. Now we're going to learn from it better. But it does happen. So don't. I don't know what it is. I guess it's like we'd have a tweet, text. Of course, it's not like a spelling mistake. The spell correct exactly did what I wanted to do. No, it didn't. Can't tell you how many things I texted. It's like, that was not the right. So, be open. So when you're practicing these things, you will get it. And the point is, like, if you see that you've gotten it, go back and look at it and say, let's try something else. So the other thing that we're going to work on is when you make a substitution in calculus. Now you're going to say u equals or theta equals or whatever letter you use. You're going to need the next step. Okay, it should be a du equals. So back when I was growing up, we have many tunes, but always the thing to do is, and you have to finish it. Okay, watch a rabbit, get that joke, but you do. It should be as naturally as finishing to get your D. You may actually not need it most of the time. Okay, so just be safe. You make a substitution, get the derivative of that substitution, so you can work it. Okay, just always as necessary. So what are we gonna do? Let's take an example. Say this is going to be f squared. Now we have the square root x cubed plus 1. Now you are not taking this and putting it in. It's just not going to work out so well for us, right? So there are some funny little tricks we could do with this, but generally, you want to avoid putting things inside of a radical unless you have to. So what do you do? Well, I can't put it inside. Can I take this out? Can I just say that this is going to be, x to the 3/2 plus 1? No, it's not a rule you have. Don't down. We'll be most on that. Okay. So what we're going to do is we're going to recast this. So we're going to say, this is a problem. So why don't we say x cubed plus 1. But next thing we have to do is write our x. Of course, this came out of a textbook, so it's going to work out. But there's a 3x squared. Do I see any 3x squareds in my problem? Oh, right there, x squared. So what we're going to do to recast this, okay, is I've got my x cubed plus 1 raised to the 1/2 power, and this in here, right? This is u, and then we've got our 3x squared x. Let me fix that. X, and here is my u. So the integral we're working with here is u to the 1/2 power times du. We could do this. This is last sections. Right? I didn't need to review this one. So yeah, this is u to the 3/2, right? We're adding so 1 plus 1/2, 3/2, divided by 3. C. So go ahead and do our little dance here. Into the fractions. So this is 2/3, and then it's u, x cubed plus 1. Don't forget the exponent here. Do that all the time. C. So how do I know it's right? Let's take the derivative and find out. What is the derivative of 2/3 x cubed plus 1 raised to the 3/2 c? So what we have, right, is we have our 2/3. Now, get down this 3/2 down in front. We're going to be applying our chain rule, so that's x cubed plus 1 to the 1/2, right? Minus 1 is 1. Times, what's our chain rule? 3x squared. We're constant, 0, so the stuff cancels, right? 2's cancel, 3's cancel, so we have x cubed plus 1 raised to the 1 times 3x squared. And go to that 0. We don't need to write. And this is exactly what we started with to have to integrate. So you can see u substitution is nothing more than, oh, we had a chain rule applied to our derivative. Now we have to undo it. We have to figure out, like, where is the chain? So that's pretty much what we're undoing. So we're undoing the derivative of the chain rule, turning it back, getting the antiderivative of that. Right? Now, let's see here. What if they don't quite match up? What if they don't quite fit? So what if I wanted to do just an x squared, right? 6 minus x cubed raised to the 5th power x. Now, one legitimate way of doing that would be to do this. Two, 3, 4, 5 for the 5 exponents. We could multiply all of this out and then multiply at the beginning by x squared and integrate them piece by piece. Now, that strikes me as more fun than should ever be allowed to have. So we're going to make a substitution. So we're going to say, well, what's the problem? Usually your guess is a thing inside of a power, inside of a radical, inside of a fraction. So we're going to set u 6 minus 3, or minus x cubed. Sorry. 6 minus x cubed. du is just going to be negative 3 squared. So the 6 is a constant. Now, I have a negative 3x squared here. I just have an x squared. So what we're going to do is we're going to insert that. So we're going to say this is going to be of 6 minus x cubed to the 5th power. There's my u, right? It's my u. And then what I'm going to do is I'm going to take negative 3, that's 1, right? Negative 3 over negative 3, that's 1. x squared. See that if I group them together this way, say, huh, here's a negative 3x squared. That's my du, isn't it? What do I do with this negative 3? Well, this shoots out in front. So we don't have, we can push this out in the beginning of the interval. So this is going to be negative 3 integral. Now this was u to the 5th. This negative 3x squared dx, that was my du. So this is going to negative 3rd, u to the 6th, 6 plus c. Now, what is 1/3 times 1/6? Right, so we can rewrite this. If it makes it easier for you to see it this way, you go right ahead and do that. So 3 times 6, that's negative 19. What's u? Is 6 minus x cubed raised to the 6th power. Let's see. You want to put the 18 directly under it? You go right ahead. That's my answer for this. Now, this is the way I learned how to integrate. This is the way I tend to use. The engineering book shows you a slightly different method. So what they do is pretty much the same idea here, right? So 6 minus x cubed. Now, when they said their du, okay, this is negative 3x squared dx. What they do now is they said, well, dx equals du over negative 3x squared. So all I did here, solve for dx. Right? So when we do our integration here, we still have our 6 minus x cubed to the 5th. So we have an x squared here. X. Okay. The original casting of the. So what we're going to do is we're going to write x squared. This part is u, so that's my u to the 5th. Now dx is equal to d over 3 squared. So you see that the squareds they cancel. This negative 3 again shoots outside of the integral sign. So we end up with third integral to the 5th. Yeah. Right? So we go ahead and integrate that. That's negative 3rd to the 6th over 6. This should start looking really familiar at this point. Negative 1, 6 minus x cubed, 6 plus c. There is our answer. Same thing we got over here. Same thing. So which one is best? Yes, they both work. They're both good. The goal here is to use the one that you see as the better way to go about this. So there isn't a right answer. I find this way, the first method. I find method 1 to be a little faster than method 2. This is the second one I showed you. So, but I have a lot more practice with method 1 because that's how they taught us that here. But it isn't the wrong way. It isn't the right way to go. They're both the right way. So if you like substitution and dealing with this, that's fine. Do it that way. And there are times where it's like, this is easier to see. I'm going to do it this way. And then there are times where it's like, I'm just interested in kind of going fast and I know kind of what the path is going. I mean, I've done the problem with the path. So I'm going to be able to do, I'll do it this way, method 1. Because for me, it's a little easier. But they're both correct. You should use the method that you feel most comfortable with, the way that speaks to you. So that's our little discussion. I'm going to caution you that just because you have a fraction doesn't mean you always get a natural log. Sometimes you do, but sometimes you don't. So don't always just assume that you've got a fraction. It's going to be a natural log. One final technique we have here is integral, say, x square root x. And again, like I can't put this inside, right? So what I'm going to do, even if I could, it's not going to help. Say that u x b, so that's 0. That's negative dx. So we're going to try to substitute here, and then we're just going to see. So I've got, so x, right, equals negative d. So this is method 2. So we have our x, we have 1 minus x, that's u, raised to the 1/2 power. Then I've got a negative, can I integrate yet? You have an x and a u in here. Can't integrate with respect to equal for within variables. It doesn't work. Get to chapter 9, there's some, we have 2 independent variables. Actually, everybody's going to be something, but u and x, they are not independent. But u depends on x. X you can pick, but whatever you pick for x, u is going to have to suffer because that's what the choice was for x. So these are not independent. Cannot just integrate this willy-nilly. Doesn't work. So if you end up with 2 different variables in your integrand inside of the integral, you're not done. There's other substitutions you can make. Okay, in this case, did I make the wrong one? No, but I didn't do everything I needed. So we're going to say, since we know u is equal to 1 x, u x is equal to 1, x is equal to 1. Yeah. Let's add x to both sides here, and then subtract. So now that I know that x is 1 over u, we're going to say this is going to be u times u to the 1/2 times negative 2u. Now, am I allowed to distribute this? Yes, I am. I'm not going inside of the square root. I'm taking the square root and multiplying it by. That's fair. So this negative is going to come outside. 1/2 to the 1/2 to the. This is 2/2, right? Bases are the same. We add the exponents, so that's a 3/2. Now we're just going to go through it. This is not so bad. So it's going to be negative. This is going to the 3/2. That's right. So if we add 2 over 2 here, 2 over 2 to do our integration, minus, this is u to the 3/2 plus 2/2, that's 5/2. Plus c. So what if it's not minus c? That's fine. We usually write plus c for the sake of keeping everything consistent. But if you write down negative c, like I'm not going to complain to you. 7 is a constant, negative 7 is a constant. You're just going to have a slightly different spelling constant. It's negative sign, constant. So we usually just leave the plus c by itself. So this is going to be, what's u is 1 minus x. So we have minus x to the 3/2. 1 over 2/3, what we're going to do is we're going to say this is the 3/2 rally. We're going to multiply top and bottom by 2/3. Minus, same thing that's going to happen here. 2/5 top and bottom. So that's going to cancel out. It's x raised to the 5/2. C. So we're going to say this is negative 2/3, 1 x to the 1/2. Minus plus, right? Because minus times a minus. 2/5, 1 minus x raised to the 5/2. C. That's your solution. You might swap them around to put the positive one first. But either way, right, this is ascending form, this is descending form, it's the same thing. So you're fine. Let's do one more of those because the book, no, the book only gives you a couple of examples. So be aware that you will probably have to face one of these at some point. Like, you know, something. So you should practice them in CVs. Let's just do it. So this is 23. So this is an integral P. It's 1/5. So I don't. Let's try all of this out. It could, but you know how much time you got on this planet, right? So we're going to say like it's equal to P plus 1 is equal to A. This is right here. This is the key to let you know that maybe it's one of these types. When your du is equal to like a constant times your d, that's what it is. Okay, make your substitution and u is equal to like 3 out here. I would still suspect like, oh, maybe it's one of these. But when you pretty much have that kind of relationship, du is dp, du is dx, or whatever, negative, or like I said, a constant thing, I would still suspect. So let's try. So I have p because I can't substitute that just yet. Then I have u to the 5th, and can't integrate 2 different things. Okay, real careful about that. You cannot into, especially, I mean, you can't integrate independent, right? And dependent variable at the same time. Both independent, sure, but we don't have that situation. So what we're going to say here, since u is equal to +1, minus 1 must be equal to b. It's pretty +1. And u to the 5th. Can I distribute this? You bet I can. So remember, the bases are the same. We add the exponents. It's going to be to the 6. And this u to the 5th integral du. Again, this is another problem where it's like, oh, well, after I made the substitution, this was easy. That's the whole. Show you like, you should make a substitution because we want to torture you. A little bit. But for the most part, make the substitution so the problem is now something we can actually do. It's 1 to the 7th. 6 equals 1 to the 5th plus arbitrary constant, and we're set. There's our answer. I think that's really all I wanted to show you with these. Don't be shy. If you're stuck on one of them, let me know. I'll do them. Some of them are a little tricky, but you know, I need to know like which examples I need to focus on. I don't want to give you the whole thing, but I do want to assist you with it. General rule of thumb. Okay. If you have nothing written down on the page after 10 minutes, you need help. Okay. By which I mean you need to talk to a tutor, talk to me, send me a I'm stuck on this problem. I don't know where to start. Then I can do a video to say, okay, this is how you do this problem. Or this is how you do a problem just like the one. So if you're staring at this after 10 minutes on a blank page, it's maybe even after 5 minutes, you don't know, then you really need to reach out and say, I'm stuck. Get me unstuck, right? And I can do that. If you're doing a problem and like you're 8 minutes in and here you are and you're like, we're almost done. That's just the learning process. I'm sorry, but you know you are well on your way of getting through it. Maybe you started, you didn't quite get through it. So, try different. That's fine. You're going to make mistakes. So if you're on the way of the process after 10 minutes, you know what you're doing. It's good. If you're stuck with 5 minutes, 10 minutes, just okay, start. Like, send me the email on number 23. I don't know where to start. Could you please show us, could you please show me an example, show a similar problem? So walk me through it. What am I looking at? Or I got this one wrong 3 times. I don't know why I'm screwing up. Okay? So I could show you the video and say, oh, most students make this mistake here, make this mistake there. Okay? So, the whole reason of having a teacher is they show you like how to help people find path. What am I looking for? What am I trying to find? So don't be shy about asking for questions. I'm not going to judge you. Shoot me an email, my video. I'm not going to say, oh, I'm shy to ask this question. I'm just going to say, some people were concerned about this question. Nobody's going to know. It's funny words. It's a group of people. Okay? So I'm not going to betray you. Just going to say, let's work past this. Right? Stop us there. It's for you as soon as I can.